Hello viewers, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created a bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming. Please check them out. I have uploaded the code for this problem to GitHub repository. You can get the link from description below this video. Let's jump into today's problem. Partitioning into minimum number of Deci-Binary numbers. A decimal number is called Deci-Binary if each of digits is either 0 or 1 without any leading zeros. So, for example, 101, 1100 are Deci-Binary, while 112 and 3001 are not. So, basically it should have either 0 or 1. Each digit in the number should be either 0 or 1 likewise, right? That's why it said 101 is a Deci-Binary number, but 112 is not a Deci-Binary number because it doesn't have only zeros and ones, right? It has 2. Similarly, 3001 also, the 3 is not a binary number, so it should have either 0 or 1, that's it, right? Without any leading zeros, of course, right? And we are given with a string that represents a positive decimal integer. Why? Return the minimum number of positive Deci-Binary numbers needed so that they sum up to n. So that's the problem. So basically we are given with a number n. Okay, so what we are saying is we are supposed to get how many minimum number of positive Deci-Binary numbers can represent up to n, right? So for example, n is equal to 32. So remember, the 32 is given as a string, not as an integer here, right? So that is a string. So, but we have to imagine that as an integer. So how many Deci-Binary numbers are really needed for us in order to get to that particular number, right? So if you look at this example 1, right, so the output is essentially 2, right? So what are the Deci-Binary numbers that will sum up to 32? There can be several different number of ways that 32 can be formed with Deci-Binary numbers, right? So for example, we can add all ones, right? 32 ones, right? So we can say 1 plus 1 plus 1 plus 1 and so on up till 32, right? 32 ones, right? That's one way. So this is one way to generate the number 32. But what is some other ways, right? So we can look at some other ways. 10 plus add 1 plus 1 plus 1 so on 1, right? So that will be 10 plus 22 ones, right? So that will be 32. That's another way. I mean, we are just saying second way, right? And we can go on, right? 10 plus 10 plus how many ones we need? Essentially 12 ones, right? So that means that is 32. This is another way. So there are multiple different ways to convert a given number by using the Deci-Binary numbers. Remember, Deci-Binary numbers should have either 0 or 1. So that's the reason why the first way we said just added all 32 ones, right? So that's one way and of doing it. So in that particular case, how many number of Deci-Binary numbers we needed? 32, right? So in this case, 22 ones and 1 0, that means 22 plus 1, that is 23. So in the first example, the output is 32, right? And in the second way, output will be how much? 23, because there are 22 ones and 110, right? Total number is 23, right? That's what we need, the minimum number of positive Deci-Binary integers, right? So the first way it was 32 ones, right? So and 23 is lesser than 32. So now so far our minimum is 23, right? And if we go look this way, right? So 10 plus 10 plus 12 ones, how much it will be? 12 ones, okay, and this is 1, 1 0, that is 10, 13th, and this is 14, right. So, this will be 14, right. So, likewise you can continue doing it, but finally what we will realize is, okay, the minimum number would be 10 plus 11 plus 11. So, that means we have output as 3 numbers, right, 3 Deci-Binary numbers. That is the minimum that you could get it, right. That is the minimum that you could get it. You can't go further down because we need to use only Deci-Binary numbers, right. So, for example, 22 plus 10, right, 22 plus 10, we could go that way, but 22 cannot be a Deci-Binary number, right, because Deci-Binary numbers need to have either 0 or 1. So, like this is like understanding behind, right. So, now how to come up with the optimal answer as 3, right. In this case, if we go through all these things and finally realize, okay, output is 3, right, that's a long process. That is so somewhat called as brute force approach, right. So, basically you go through all the different combinations that are available and then go from there, right. So, that is a brute force approach. So, we will look at a different kind of approach, how we are going to really look for, right. So, given a number, we will consider the same example 32, right. So, in our case, so since we know the output is all about the minimum number of positive Deci-Binary numbers, right, and for Deci-Binary numbers we just have only 2 choices, right. For a number to construct, at each digit it could be either 0 or a 1, that is it. We do not have many choices, we just have only 2 choices. So, that information we are going to use. So, that means we just have only 2 choices, right. So, now at each digit, right, at each digit we will see, can we subtract 1 from there, right, can we subtract 1 from there. I know. So, here we were just adding them, right, 10 plus 11 plus 11 is 32. So, now we will look at the approach where we will be subtracting these Deci-Binary numbers from the given number, right. So, now given number is 32. So, at digit 1, right, at digit 1, can we really subtract anything? Yes, we can subtract 1, right, and at digit 2, can we subtract anything? Yes, we can subtract 1. So, what it will become if you do minus, right, from 32, it will become 21, right. So, that means so far we have used 1 Deci-Binary number. So, count, we will keep track, right, count is 1, and now the number is 21. Again we are going to do the same approach at a digit, first digit from the leftmost, right. Can we do a subtract of 1, right? Yes. So, negative 1, and the second digit, can we do subtract of 1? Yes, good. So, that means 21 minus 11, it will be 10, right. So, now we are going to update our count to 2, right, good, and we are left with 10 now. So, from 1, can we subtract anything? Yes, 1, and from 0 you can't really subtract anything, 0, right. So, it will be 0, right. So, now 10 minus 10, right. So, that will be 0, that is the answer now we want. So, basically what we are trying to do is, you are given with a number and try to decompose that number to 0, so that while you keep track of how many Deci-Binary numbers you had to do, that would give you the answer, right. So, this is sounding quite simple, right. So, you have done like 3 times subtraction of that number and then you are done, right. So, let us see if this is applicable for any other bigger number, right. So, let us say 15 or smaller number, that is not a problem. So, 15, what we are going to do is similar, right, minus 1 1, that means our count is 1 now, right? So what will be the number? We are done with 4, right? From 4, 15 minus 11 is 4, right? From 4, can you subtract any Deci-Binary number? Obviously, we can subtract 1, right? So if we subtract 1, the leftover number will be 3. So we are saying count will be updated, right? 2. And from 3, we will subtract, we can only subtract 1, right? That means we are left with 2 and our count is 3. And from 2, we will subtract 1, we are left with 1 and count is 4, right? And 1, we subtract 1, we are left with 0 and our count will be 5, because 4 plus 1, right? We will just keep updating. So that means 15, the number is there, and in order to decompose 15 into Deci-Binary numbers, we need 5 numbers. What are those 5 numbers? 11 plus 1 plus 1 plus 1 plus 1. That's it. That is the representation, right? So in the case of 32, we needed 3, but in case of 15, we needed 5, right? So that is next better approach than brute force, right? So in this case, we are trying to construct the Deci-Binary number and subtract it. But do we really need to do this, right? So do we really need to do this? So since the number is like 15, 32, we are able to do all this subtraction calculation and get done with it, right? But so if you look at the example 3, right, it has more number of digits, right? And if you look at the problem constraint, right, so it has the length up till 10 to the 5, right? So that is 100k digits are possible. That is such a big number. It doesn't really fit in any of the ranges, right? So do you really want to do this kind of subtraction and keep on counting? So there is not required, okay? This method, whatever we have been doing, like subtracting the number and keep incrementing the count, that's good as long as the numbers are smaller. But if the number of digits in the number is 100k, right, you don't want to do that long, right? Because that number cannot fit in the any size of the integers, right, or even long. So the better way is, if you closely observe here, right, if you closely observe here, what we are essentially trying to do, we are trying to decompose the given number, whatever it is there, right, at each digit we are trying to decompose that to 0, right? So that comes down to, we are trying to decompose 3 to 0. So how many steps are needed in order to make from 3 to 0? For example, your number is 3, right? 3 to 0. How many steps are needed, right? Obviously 3 steps, right? 1 plus 1 plus 1. That's it. So for a given number, in order to decompose, all you need is 3 steps. Simple. And you have 3. So for 3, you need 3 steps. And for 2, if you convert into the similar logic, right, all you need is 2 steps. So for the digit 3, you need 3 steps. For the digit 2, you need 2 steps. So you just take the max out of both, right? You just take the max out of both. So essentially, what does it mean is, when you have the numbers 0 to 9, right, for decomposing 0 to 0, you just need 0 steps. Because decomposing 1 to 1, you need 1 steps, right? For 3, you need 3. For 2, you need 2. For 9, you need 9, right? So what does it say? Given how much ever the length of the number, for example, this 3, example 3, right, you have this much big number, but how many decompositions are needed? Remember, we are looking for minimum number of positive Deci-Binary numbers. we were not looking for maximum, right? We were looking at minimum number. So how much is that minimum number? So that sounds to be whatever the maximum digit that you have in the given number, right? So what is the maximum digit here in the given number? 3. So the answer is 3. So what is the maximum digit in 15? 5. So the answer is 5, right? We said answer is 5 here. So in this particular case, what is the maximum digit here, right? Let me paste it here so that we can see it, right? So what is the maximum digit that is available here? It's 9, right? So that means answer is 9 for this, right? Answer is 9. So simply, do you need any more information to get it converted? All you need is whatever the string that you are given, and you are looking to find out what is the maximum digit. Remember, maximum digit it is, right? So 2, 7, 3, 4, 6, 2, 0, 9 is the maximum, right? Out of all the digits that are available, right? So for example, if the number is, let's say 111, how many digits, how many Deci-Binary numbers are needed? Just 1, that itself, because that itself is Deci-Binary number, right? So for this, answer is 1. That's it. So now that we have looked at like 3 different approaches, one is basically the brute force, and then second one is we were trying to construct and divide or decompose that number so that it becomes 0 while keeping track of the counts. And another simpler approach is all we care about is what is the maximum digit that is available, right, in the given string. So the maximum digit gives you the answer for you, right? So that is a simple implementation that we are going to look at, right? So now that we have gone through all the 3 approaches, the code that I am going to show you is for the last approach, which is simpler than the first and second, obviously, right? So, and the code is very simple. Even though we went through all the different options here, the code is pretty simple here, right? So we initialize m to be 0, right? That means we will start with 0. For each c in the number, right, whatever the given string, we will calculate the max, and before returning, we will convert that max to integer and return. That's it, right? The code is very simple. Hope it made sense to all you guys. If you have any questions, please post them in the comment section below this video. I have posted this code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to my channel, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye. Thank you.